In our next example of how we introduce work done on objects or work done and energy expended, here we have a person that's carrying a box. Let's say the box has mass m, and the person is carrying it from point A to point B at a certain distance x. And the question is, how much work does that take? Now, of course, anybody that's ever carried a box from point A to point B, however far point A and point B are apart from one another, they would always say that takes work. You get tired, your arms get tired. But in the terms of physics, is the person actually doing work? So let's try to figure that out. First of all, we should identify all the forces acting on the box. So we have the force of gravity pulling the box down, and then we have the reactionary force. Newton's third law says that there's an equal and opposite force going in opposite direction, which is the normal force, which has a magnitude equal to mg, just pointing in the opposite direction. So those two forces cancel each other out, and there's no acceleration in the vertical direction. We also specify that the person is walking at a constant velocity, holding the box steady, moving like this from point A to point B at a constant velocity. So does that require a force? Must the force push against the box to keep it moving forward? To get it going, yes. So the first initial part where the person begins to walk from a standing position, it does require some work. But once the person reaches a constant velocity and then keeps moving at a constant velocity, and the box is therefore moving forward at a constant velocity, it no longer requires any force to keep it moving. That's Newton's first law. Newton said once the body is in motion, it will remain in motion forever until some force comes along to stop it. So there doesn't need to be even any friction between the hand and the box. Once the box is moving, even with no friction between the surface of the box and the surface of the hand, the box will keep on moving forward. The hand simply needs to be there from keeping it from falling to the ground, holding it up against gravity, which means that the force in the x direction is equal to 0. So now when we calculate the force done to move the box, we know that the work done, I should say, not force and work done, is equal to the force dotted by the displacement x. We know that this is equal to 0 dot x, and so it doesn't matter how far you move it, since there's no force required, there is no work done. 0 joules of work required, no matter how far you carry that box. The reason why you're getting tired is because you're holding it up against gravity and your muscles begin to get tired, especially when it's a heavy box. But to move it forward, no work required. And that is that, surprisingly enough.